back to Spring Into Math 8. Today we're going to be doing a review lesson on all the topics we've covered in Chapter 14. The first topic we covered so far in this chapter was the idea of Pythagorean theorem. There was a very crucial vocabulary word that we needed to work with when looking at this lesson. That word is hypotenuse. And here we have a nice illustration that shows you not only where the hypotenuse falls on a right triangle, but also the definition of it. The hypotenuse, the longest side of a right triangle opposite of the right angle. Now here in our illustration we have side A labeled, side B labeled, and even the hypotenuse labeled for us directly opposite of the 90-degree angle. Don't forget that the hypotenuse side is also referred to by the letter C. The formula we use to solve the Pythagorean theorem is a squared plus b squared equals c squared. We're going to go ahead and walk through a problem together to get a little extra practice. It says, find the length of the hypotenuse. Well, they gave us two sides of our triangle, which makes solving this problem pretty simple. We have 15 squared plus 8 squared. So let's insert that into the formula. So, like I said before, we have 8 squared plus 15 squared equals c squared. Now, when we go ahead and square 8, it's 8 times 8, so we get 64. And 15 squared is 225. So we have 64 plus 225 equals c squared. So when I add 64 and 225 together, I get the number 289. And I haven't done anything with c squared, so I'm simply going to bring that part down in our equation so we can use it in the next step. Now, to get rid of the squared part of our c, we must take the square root of both sides of our equation, and we do it to both sides in order to help keep our equation balanced. So taking the square root of 289, I'm looking for a number when multiplied by itself gives me 289. In this particular case, by taking the square root of 289, we get a whole number of 17. The squared part of our c goes away because we took the square root, and we're left with our final answer, which is the length of the hypotenuse we are looking for. In this case, it was 17. The second topic we talked about in this chapter was Pythagorean theorem proofs and its converse. Remember that the Pythagorean theorem is used as the following. It says that in a right triangle, the square of a hypotenuse is equal to the square or the sums of the squares of the other two legs of the triangle. Now, the converse theory of Pythagorean theorem is used to help prove that a triangle happens to be a right triangle. Remember, Pythagorean theorem only works when we're looking at right triangles. You may be asking yourself, how do I identify a right triangle from other types of triangles? Well, if the equation of a plus b equals c is true for the side lengths of the triangles, then the triangle is a right triangle. Sometimes you'll be asked to identify whether a triangle is a right triangle or not. So let's go ahead and see if we can learn to identify them. Over here on one side of our illustration we have a green triangle. Now this green triangle has specific measurements we're going to use by inserting them into the Pythagorean theorem formula to check to make sure it does happen to be a right triangle. So a squared plus b squared equals c squared. We're very familiar with this formula by now. So let's insert sides a and b. 9 and 41 are inserted into our equation. I'm squaring 9, I'm squaring 40. So 9 squared is 81, and 40 squared is 1600. I can't forget to also insert the c part of my equation, which in this case is 41. Well, I squared 41 and I got 1681. Now when I add 81 plus 1600 on the other side of my equation, I get 1681 equals 1681. These two numbers happen to equal each other, and therefore we can say that this green triangle is a right triangle. Now the converse theory can be used also to show us that the triangle is not a right triangle. So I have some numbers here on my side lengths of 18, 24, and 12. I'm inserting them into our equation to see if this is a right triangle or not. So 12 squared plus 18 squared equals 24 squared. When we square all those numbers, we find out that 144 plus 324 does not equal 576. So we can say with confidence that this red triangle is not a right triangle. The third part of this chapter we discussed using Pythagorean theorem on a coordinate plane system. So we're going to apply the Pythagorean theorem to find the distance between 2 points on a coordinate plane. We have our coordinate plane here, we have our triangle. Let's go ahead and apply it together. So we have to find the measurement lengths of side A and side B. And we found those by counting the number of units on the coordinate plane. So the distance on side A is 8 units, and the distance on leg B is 9 units. So we've gone ahead and inserted that onto our illustration of our triangle. We've labeled side A as 8, side B as 9, and we are looking to find side C. We're going to go ahead and insert those numbers into the Pythagorean theorem equation and solve. So 8 squared plus 9 squared equals C squared. Then we get 64 and 81 by squaring both 8 and 9. We add the two together, we get 145. And we're bringing down C squared each time because we haven't quite used that part of the equation yet. So right now I have 145 equals C squared. I got to take the square root of both sides of my equation to help keep it balanced. And by taking the square root, I'm getting rid of the squared part of our C and reducing 145 down to 12.04. So we can say now that the three lengths of our triangle are 8, 9, and 12.04. The fourth topic of this chapter was Pythagorean theorem and the distance between 2 points. This is where we learn to use the distance formula to solve the distance between any 2 points on the coordinate plane. Here is the distance formula listed for you. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is used when asked to find the distance between 2 points on a coordinate plane. Insert the coordinates you have and solve from there. So we're going to go ahead and try this out with using the coordinates -3, 5 and 4, -2. So go ahead and insert those into their proper places in the equation and we'll start solving from there. I went ahead and inserted them in the proper place. Now my equation reads D, which stands for distance, equals the square root of -3 minus 4 squared plus 5 minus -2 squared. I'm simplifying and reducing each part of this equation. I get -7 squared plus 7 squared. I square both those numbers and I get 49 plus 49. Don't forget, when you square a negative number, the two negatives cancel each other out, making that nice positive number. I add 49 together and I get 98. Now all I have left to do is take the square root of 98. When I do this, I find out that the distance between those particular two coordinates was 9.89. That's it for now. Catch you next time.